Thank you so much for joining. And today we're going to be talking about pro troubleshooting of electric floor heating, which is a step-by-step guide. I'm joined by Anatoly from our tech support department. Hello, Anatoly.
Hello.
And I'm going to make sure that I can click on my display here and we can move forward. If you have any questions, feel free to ask. That's why we're here. Just go ahead and type your question into the Ask a Question section here, and we will be glad to help you out any way we can. So going over the webinar overview, today we're going to be talking about the introduction to electric floor heating, initial diagnostic procedures, advanced fault location techniques, thermal imaging for precise area of fault location, repairing the identified fault, and preventive measure and floor restoration. So we're going to have some videos in here that actually shows how to do this stuff. So stick around to the end. We'll actually show you how to do these repairs. But Anatoly and I both work in the tech support department, and we, if you're here for any matter of time, you're going to run into very, very similar questions asked very, very often. So what we've decided to do here is to try to help you troubleshoot. Maybe you don't need to repair your floor. Maybe it's nothing to do with the floor. So let's talk about those things first. So Anatoly, tell us about the Smart Stat. Most people are probably very familiar with this.
Yeah, the unit that was on the market probably for quite some time, kind of back in the days, might still maybe be sold today or no, but it's definitely on the walls of a lot of customers who have a floor heating system. And we were talking about, yeah, maybe we don't need to repair any floor heating, maybe it just stopped. And the first thing would be to go and look at that thermostat, because that's the device that controls that. And number one, the very simple testing troubleshooting that you can possibly do is, yeah, look at your thermostat. If it's blank and you know there's power coming to this unit, that maybe you tested it or you just know that the wiring is all good, that just means that thermostat needs to be replaced. It's as simple as that. You might be dealing with the story number two. That unit might look like it's working, but it's kind of showing you random numbers. Those numbers are flashing or going kind of in the same cycle over and over and over again. That just means that thermostat is trying to boot up, it's trying to start, but it just cannot do that anymore. And that would be another reason, another kind of case where the thermostat simply needs to be replaced. And of course, the more complex thing is your thermostat looks fine, just like it's on the picture. It's 80 degrees, or maybe it's set to 80 degrees, but it's not heating up. The floor is still cold. That's where ideally you just want to do an ohms test, confirm that your heating element is good. And if that's the case, then the thermostat needs to be replaced. Here's your top three, right?
Yeah. So what we do is just rule out the floor. A lot of times we just rule out the floor. If it's good, then it has to be something else. We have Olivia who runs these, and she's in the background here. But Olivia, there was someone, it looks like Corey has mentioned that his screen has no video. Does everybody else have video? Is there a problem with the video that I'm not aware of?
Yeah, feel free to chat us if it's everyone. In the meantime, I can probably, since we're troubleshooting, I see we have a Q&A part from Ken, who's asking, is there anything that can be done when hooking up electrically that could damage the system downstream from the thermostat? Oh, good question, Ken. I think what we're trying to cover here is supplying the voltage to the thermostat. And to, I think, answer your question, if I fully understood, yes, if you have a system that is a 120 floor heating system, but electrician by mistake supplied a 240 volt power to it or 240 volt voltage to it, yes, that eventually will overheat and damage the system unless it was just hooked up and maybe turned on for a second or two. Right, Scott?
Yes. Yeah. With this question, that's a great question, Ken. This is a situation where a lot of electricians think oh, that's floor heating, that has to be 240. Well, that's not true. Most of our floor heating in bathrooms is 120. because you don't need 240 until you go over 120 square feet. Then you need 240. So 240 is not more efficient than 120 when it comes to floor heat. So you don't have to worry about that. And using 120 instead of 240 lets you save a space in your breaker box. So you're using that instead of two spaces. So very, very good question. So another question that we get all the time, or a statement that we get all the time is, especially on new installations and sometimes on older ones too, is part of my floor heats and part of it doesn't. So this is an example of a large installation. And Anatoly, what is on this this drawing that you or I would look at in the tech support department and go, why would part of this floor work and part of it not?
Yeah, good example. So we may just quickly start by saying your typically smaller to medium size systems would be connected to one single thermostat and they operate as one thing. Example here is a relatively larger project that has 4 different mats, and circled in orange are 4 different units they are connected to. So to make the matter simple, if you have a red mat connected to the main thermostat and that red area is working, we know that part is all fine, but maybe your green mat is the only one, or that green area is the only area that's not working, and it's connected to a completely separate device called power module that can immediately isolate the issue to either that mat or to just that one power module. So that's your typical number one place to start and understand if it's one thermostat setup, or maybe it's a setup that has multiple power modules, and troubleshoot from there.
Why is this, why don't we just hook all these mats or rolls up to the thermostat? Why are we using all these other controls?
Yeah, so industry over the time eventually got to the point where almost every single floor heating thermostat on the market has a built-in relay that can handle up to 15 amps. And 15 amps, it's typically, like I said earlier, plenty for your small to maybe medium size floor heating project. But here we're dealing with a large project, and that's why we need to expand. Pretty much, we need an expansion unit. That's how sometimes people call it as well, to connect this 10 amps or another 12 amps or another 15 amps to separate unit to spread that load evenly.
Yeah, the thing to keep in mind is this power module needs its own power supply. This one needs its, and that means its own breaker. This one needs its own breaker. This one needs its own breaker, and this one needs its own breaker. So there are 4 breakers powering this room. Each one talks to each other with a low voltage connection, which means you're going to need to run a daisy chain from thermostat to P1 to P2 to P3. And that means that um, if the connection that they talk through is broken up, there's another possibility of one part of the system not working. So part thermostat P1, P2, these roles are all working. P3 is not. Well, what we would do first is we always test for ohms of the mat first, or of the cable first. And if this would test good, then it tells us that there's not a problem in the floor. The problem is in this power module, or the breakers tripped, or the connection between these two is not good, or not good any longer. So that's why all of our testing starts with ohms, 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 over and over and over again, and not a continuity checker. That's not the same thing. You want a digital ohm meter, and that's always the first step of troubleshooting, is to use that. Okay, so Kenneth has a question I think we need to just talk about at the end, because it's quite an involved personal thing. We'll be glad to do that, but we'll just save Kenneth's questions for the end. Mike has a question we can talk about right now, because we are talking about
Yeah.
power modules. And Anatoly, you and I spoke exactly about this morning. What's the benefit does the power unit have over using another thermostat?
Yeah, good question. So, in this particular situation, let's just say it's a one large room that you want to control at the same schedule or at the same temperature, or you want pretty much this whole area act as just one large system. You want to have a thermostat in the module because that allows you to just have one device with one simple control. You dial the temperature to 80 degrees and the whole thing works and warms up uniformly. On the opposite note, if that would be something like a living room and a dining room that has maybe an open kind of concept, but on some days you may just want to have your living room running at a higher temperature and the dining room either lower temperature or set back or completely off. That's where, of course, you're going to benefit from having two independent controls because each independent control or thermostat will be able to control the floor at its own temperature.
And once again, for people that are interested in this but have never used it, one thing that we never recommend or very rarely recommend is putting one thermostat in your house and then running all your rooms off of that thermostat, because electric floor heating is a zoned product where there's no need to heat the whole house if you're sitting in your living room. So that's why we always strongly suggest, if you're doing a whole house of floor heat, that you put a thermostat in each space, because there's no need to have the whole house on, especially like in a basement. In the Midwest, we have basements, and basements, there might be a bedroom down there, and that bedroom gets used at Thanksgiving and it gets used at Christmas. There's no need for that to be on every other day of the year. That's why you would use thermostats in each individual areas. But if you're in a large room like a living room or this particular space here, that's where you would use a thermostat and power modules, because you're controlling that area. But you never, or you can never say never. Rarely, if ever, do we suggest using one thermostat to heat the whole house. That's forced air. That's not floor heating. So very good job on that question, Mike. So a lot of times, if our product wasn't any good, we would have been out of business a long time ago, right? So
Yep.
we make a quality product, we back it up with quality technical support and sales support and customer support, and we don't run into very, very many problems with our heating cable as long as it's installed correctly. What we're talking about now is stuff that often happens out of our control, out on the job site. And we get these questions all the time. And you simply can see 3 pictures here that we've supplied of these are installation problems. It's not the wire's fault that it doesn't heat up anymore if somebody puts a drain through it or if someone installs a water pipe through it. That nothing can withstand that. So those are the kind of things that happen during the installation. So Anatoly, can you cover some of those installation issues that we're up against quite often here?
Yeah, 100%. Let's kind of start in the order that we have on the screen. So first image all the way to the left showing us a cable, right? And we can clearly see there's a hole. There's a pretty much a nail or a screw went through that wire, damaged that wire. Very likely that was during nailed down wood flooring installation. Maybe that spacing or sleeper orientation was not followed. But yeah, that's just a direct damage to the wire, and that's what we're going to be talking later in slide, how to correct that.
And that
Uh,
also is a possibility of someone that was doing trim. So people putting trim nails are often putting them in an angle, and they go down, and sometimes the wire is close and it bounces off there and hits the wire. So yes, right there
yeah.
is a perfect example of that. What about the next one?
Yeah, number two is very interesting. So first of all, that's an image from a thermal camera. So it's a thermal image taken with a thermal camera over a tile surface, but because the way that that whole equipment works, it tells us the temperature of the surface. That's how we can actually see the outline of the wire. We can see literally a position of the wire under that tile. And in this case, again, we only can speculate something happened and that heating system or section of it was not installed per plan, and some section is not covered at all. There is a triangular section that doesn't have a heating element. Pretty much anytime you see a blue color that means it's a cold surface and it's not going to be heated. And the answer why it's not heated is simply because there's no heating element installed under it.
Yeah, when someone calls us and says my floor has cold spots in it, this is what you have to do. You have to get a thermal camera because thermal cameras are no longer that expensive. You can rent them at Home Depot, among other places. So you can, if there's ever a question is, why is my floor hotter here than it is over there? You can figure that out using a thermal camera. It's going to answer all your questions. So if you look here under the 81.7, look how dark blue that is. And this is only literally not very far from the heating wire. The heating wire, when we put it on mats, is spaced 3 inches apart. That's because the heat travels laterally 1.5 inches in either direction. So that's why it's not one single line. You see a hotter spot, but see how the temperatures down here, they are nice and smooth. There are no cold spots here because of the spacing. But as soon as you move that, this is literally about 2.5 inches or 3 inches away. Look at the temperature difference between 85 to 86 or 82 to a temperature down in the 70s, literally just inches away. That's why, and a lot of people that do their first install go, oh, I'll just kind of spread it out over here, or I'll run the mat right down the middle of the room. Why is my floor cold on either side? I thought it went out laterally and warmed everything. It doesn't. It only travels about 1.5 inches each direction off of the cable. So talk about this next one. What do we see that's going on here? Just looking at this picture to me indicates that they might have a freestanding tub in this bathroom.
Yeah, yeah. First of all, it's a different product, heating product that's installed there. You can see a green mesh and a blue wire there. So that's our temp zone mat product that has a blue wire pre-attached to the mesh. But yeah, there was some plumbing work. Again, we can speculate. There was some plumbing work done after the fact, and that heating system layout or information or general knowledge was not shared to the person doing that work, and that pipe went right through the cables. So again, another example of incorrect installation, but also the potential troubleshootings that can be done later on to get that resolved.
So the installation errors, one of the biggest ones is I have too much cable or I have too much mat, so I cut the end off. You can't do that. You can never ever cut a heating cable that goes in the floor like this. You can never shorten it. You can never lengthen it. If you cut your cable, it's going to overheat. It's going to fail. Another question we get all of the time is, why did my floor work for insert your amount of time here? Why did it work for 1 day and then quit? Why did it work for 2 years and then quit? Why did it work 12 years and finally just quit working? This picture on the left is a picture of what happens when you don't sever the wire. If you look in the picture on the right, that wire is severed. They drilled right through it. It just stops there. This side over here, where the nail has gone through it, that wire, even though there's a nail in it, is so resilient that it might work for a day, or it might work for 2 days. It may work for 10 years. And then finally, after that cable heats up and contracts, heats up, expands, and cools off and contracts, doing that for years on end, finally makes the elements inside one of them just burn up. And that's why, and I can't tell you the number of times in my 17 or 18 years here, I've had that question. Why did it work for a while and then quit? And usually because that's of installation damage. It got nicked, and this could be either a nail, it could be a trowel hit. Somebody may have dropped a hammer on it. There's somebody put a very heavy, like those big pails that you get at Home Depot, full of thin set, and they dropped it, and that lands on the cable and smashes it. It's those kind of things that can make a wire work for a little while and then quit working. So those are common installation errors that we get. We have a question from Peter. Once again, it's a very individual type question. So Peter, we're going to answer your question, but we're going to wait till the end because that way we can continue moving on, and then we'll get to you at the end with everybody still here. So what can people do about planning. What do they need to do when they plan? The number one thing I see is they forget to tell us where there are air vents in the floor, where there is going to be plumbing, like the picture right before. They forgot that they were
Yep.
going to put a standalone tub there. And if they're in a basement, we can't heat columns. It has to go around columns. You can't heat over vents. And I can't tell you the number of times I've seen a wire get hit by the metal air vent getting shoved down that hole. So what are some things you can plan for when you're planning your project?
Yeah, so just like Scott said, definitely plan for any obstructions on the floor. We want to heat the floor that you're going to walk on, that's open, that's not going to be covered by any kind of permanent closed bottom furniture, things like that. But also, if we're talking about basements or simply any installations over a concrete subfloor, the biggest thing here is to ensure that the heating system is installed over a layer of thermal sheet underlayment first and not directly onto the subfloor. The thermal image here again showing us how great of an effect on the heating system that sheet insulation makes. You can see how all the area here besides, except that upper left corner here is having thermal sheet under it, and it heats nicely, uniformly. It heats to perfect temperature you want. However, anytime you simply remove or don't install a thermal sheet, just like in that example on the upper left, you now have a significantly colder floor, a floor that takes much longer time to heat, the floor that will use more energy to heat, and of course, depending on that weather outside, or if that concrete subfloor is really cold, it may not even feel like it's heating.
Right. So we talk to people who say, you know what, I don't think I want to spend the extra money on the thermal sheet. And what we tell them is, well, that choice is up to you, but I need to let you know that you're going from a floor that can get into the 80s of temperature wise, a floor heat of into the 80s. And if you don't use thermal sheet, you're going to have temperatures in the 60s to 70s because you're heating the whole slab. You're not really heating the floor above it. Our product is designed to be in a thin set bed, a very thin bed of thin set. And we want to get the heat as close to the surface as we can. So you can see here, you're going from a warm floor. You can hit a warm floor by using thermal sheet, or you can get a floor that isn't cold. And isn't cold isn't worth the time and effort to a lot of people to do that. So you want to do floor heating that actually gets warm. And you can see, I personally took this picture, and you can see in this sunroom, we actually left this area uninsulated, and you can see right where the product is not. So you can see this non-insulated area, that there is no thermal sheet here. And that heat, you can see it just stops. It gets sucked down into the slab. That's why it's so important to know that. So you want to make sure that you are doing that ahead of time. That's a very, very key takeaway in the planning part. So the next question is, and we get this one all the time, is what do I do if I forgot to install the sensor? Because the sensor was in the thermostat box and no one saw it and I forgot all about it. Well, one of the things we've done to fix that is we attach a thermostat sensor to every heating product that goes out the door. So there's always a sensor with it. And there's also one in the thermostat box. So what else can people do if they've forgotten to do that, Anatoly?
Yeah, great. I'm first of all personally very happy we are now having the sensors in multiple places. So I feel like that issue is slowly fading away, and we're not going to have that slide maybe next year. But yeah, let's just say that system was installed, that sensor was not installed. Uh, I think number one question that comes pretty often here is like, okay, yeah, I know sensor was not installed. I still want to turn it on. I want to make sure it works. I want to test it. Number one thing you can do is always change your thermostat sensor application to an ambient or simply room temperature mode. That means the thermostat will be using its own built-in air temperature sensor. So it's not going to throw any errors at you. It will still energize the system. Again, that's a simple temporary fix for something like this, but at least you can get the system running. But of course, long-term process here would be ideally to retrofit that sensor. And typically, the easiest place to retrofit the sensor would be to put it into the ground line, just like it's shown on the image here. You ideally want to avoid a ground line that's directly over the heating wire. And if you ask how do you find that out, thermal camera. I feel like we talk about thermal cameras a lot today. So yeah, that's another perfect use for it. You scan the floor while it's running. You can see the loops just like we've seen on the previous images. You can mark or pick the perfect ground line to place that sensor. And keep in mind, if you run into a situation like that, give us a call. We have a special retrofit sensor that you can purchase. That's the sensor again shown on the image here. It has a very tiny sensor tip that would usually fit in most of your ground lines. And yeah, eventually route that wire back to the thermostat, and hopefully that problem is solved.
Yeah, there's really two rules when it comes to doing this. The first rule is that you don't put it over a heating wire. And the second thing is that you put it into the heated area. I've talked to dozens of people over my tenure here where we tell them to retrofit the sensor in, but they only stick it right by the wall where there's no heat. And they say, I'm still getting a cold floor. Well, if you look out in the middle of the floor, it's hot. Your sensor just isn't installed in the heated area between two of the heating wires. Those are the two things that you need to do to get it to work correctly. So identifying system damage. Now we've gone past the situation where the thermostat isn't working correctly. We're talking about now, we are talking about stuff that happens usually, during the installation. And we see a lot of it. If you take a look at here's the number one thing I see. This red spot is where there's a short. Okay, we're heating the product. We're going to be talking about how we do this in the future coming up, but there is a short here. Well, look where that short is associated with. That short is associated with a grout line. The biggest harm that you can do when you're doing your tile installation is not cleaning your grout lines as you go, but coming back later with a grout knife or with a really sharp blade and start to clean the grout lines out. I can't tell you the number of hundreds of photos that we've seen like this. My first job that I ever did years and years ago to go out and fix a floor was this exact same case. We fixed the first spot that was here, and then we fixed a second spot that was over here. And then finally the tiler said, you might as well stop because I cleaned the grout lines and I did this to every single grout line. That's why you clean the grout lines with thin set, with a toothbrush as you go, or a rag or something, because the last thing you want to do is get in there with a sharp knife. So we've already had some questions about how to troubleshoot, and this is where people do partial ohms readings. What is the number one thing we see when we get ohms readings, Anatoly, that when an ohm reading isn't really that good to us?
Yeah, I mean, I would say probably 8 times out of 10, your main core-to-core resistance or your circuit resistance still might be intact. Like your label says it's 25 ohms and you test it, it says it's 25 ohms. And you might think, yeah, my system is still fine. It's something else. But there are two more tests that needs to be done that test for short, so resistance between your core wire and the ground, and that's where the short can be found. So we're going to be talking about that in just a few moments here about the actual testing, step-by-step process. But I like how this slide and kind of the process kind of connects to the thermostat. Like we covered 3 different things, like your thermostat might be bad, your thermostat might not be booting up right. But then eventually you might get to the point, yeah, my thermostat is working, I did the ohm test, and it shows the short. So that would be one indication, of course, that tells you that, yes, something is actually wrong with your floor heating system, not a thermostat. Your thermostat may also show you a ground fault message or GFI message, which will also indicate that there is a short in your floor. So yeah, again, both of these conditions can easily be tested with a meter. We already covered a number of situations how that wire can be tested. Ideally, you want to avoid that by simply putting a circuit check on your heating system while you working with that, while you're doing the install, while you covering that with thin set, with tile, with any flooring you're working on. That circuit check is a simple monitoring tool that immediately gives you an audible alarm, a beeping, if there is a short or a break. So always keep that on. That's literally a lifesaver.
Yeah, and the circuit check is not a substitute for digital ohm meter. But the main takeaway from this is there's not one ohm reading, there's three. And
Yep.
the number of times we've got, well, my ohms are good. What about the ground ohms? I didn't do those. So that's very, very important to do that. So let's see how to test with an ohm meter. And I don't think we need to talk about this too much because we're going to be watching a video that shows how this is done. But with our twin heating product and with most twin heating products on the market, you've got a black, and I can tell you for us, because we followed the old National Electric Code rules and made the color coding tell you what type of floor you have. So if you have black and yellow, this is 120 volts. If this is black and red, that means 240 volts. That way you can tell when you take your thermostat out of the wall. I've got a red and black wire running down to my floor, and if it's by our product, you know it's 240. And then you can see the ground. So the first test is across here. The next tests are to ground. So let's go ahead and take a look at this video. If your thermostat displays GFI on the screen, it's telling you that it thinks it sees a ground fault. And that ground fault sometimes is in the wire that's coming up from the roll or the system in your floor. Sometimes it's because you have a GFCI protected circuit breaker in your circuit breaker box. One important thing to remember is if you have a GFI circuit breaker in your box and you have a GFI controller in your thermostat, those two could fight one another. So the idea is our thermostats have GFIs built into them, so you do not need a GFCI protected breaker. So if you have a GFI problem, give us a call and we can send you this sheet. This is the ohms reading guide. This will tell you how to do the test on the cable. Today we're just going to talk real quickly on how to do it in real life. So to do this, all you're going to need is a digital ohm meter. And on this digital ohm meter, we want to see if we're getting ohms across these two resistance wires and if we're getting resistance between the resistant wire and the ground or the other resistance wire and the ground. So the simple test is put the probes on the yellow and black. This is yellow and black because this system is 120. If this were 240, it would be red and black. We should be getting ohms here. We should not be getting ohms from the yellow or red wire to ground. So you want to see if your ohm meter is giving you any ohms readings. It should be displaying OF or a 1 or INF. You should not be getting any ohms numbers across this. The same with the black to ground. These numbers should be INF, OF, or just a 1. Well, I'm just going to hold this here really quick. We're kind of going off script here, but what I want to do is I want everybody to notice that this is a very simple digital ohm meter. And the simpler, the better. Because see here, you can physically set the range to 200. So that's where you want to be on 90% of our heating systems. If you're testing the sensor, you're going to be at the 20K. The thing is, the reason why I'm stopping this and talking about it is because self-ranging meters may sometimes work here. Otherwise, you have to hit range, and just hit that button repeatedly until you get a good reading. But if you use a self-ranging meter and you then use it to test your sensor, sometimes the self-ranging meter doesn't recognize the 20K range and it'll tell you that there's a problem with your sensor when there really isn't. So if you had your druthers and you're going out to buy a meter, get one that you can physically set the range to 200 and 20K, just like on this picture. Displaying. So to recap,
and I think real
you
quick,
don't want any reading
definitely
from
avoid
the
the
black
analog
wire.
meters.
Yes, no analog meters, exactly.
To ground or from the yellow or red wire to ground. And that's how you troubleshoot a GFI issue with the WarmlyYours system.
Okay, so very simple on how to use a digital ohm meter. The next thing is sometimes there's not enough electricity in that 9-volt battery in the digital ohm meter to actually make the current jump from the ground into the heater, or vice versa, I should say, from the heater into ground. It only does it at higher voltages. And this is where you're going to want to take note of this tool, Peter. Peter had a question earlier. This is a test that your electrician is probably going to want to use to help figure out your problem. This is a mega ohm meter. How is a mega ohm meter different than the digital ohm meter that we've already seen?
Yeah, so the mega ohmmeter is not going to be sending that quick signal to do the test at a 9-volt or something. You actually have a selector, and in our case, we want to do that test at a 500-volt level. And just like Scott was saying a moment ago, that higher voltage is what gives us a better detection if there is a very, let's say, hard to detect short. So yeah, it sends that high voltage of 500 volts down the wires to eventually determine, is there a short, is there an insulation fault that needs to be troubleshot or no?
So let's take a quick look at how to use this meter.
So to do that, I just take my black clamp and I attach it to the ground. I then set my mega ohm meter to 500 volts. And at that point, I take this wire and I am going to go, I'm on the ground now, so I'm going to go from yellow to ground. And I'm testing it, and it tests infinity, which is good. Sometimes it'll say OL, depends on what you're getting there. But what you want to do is that means that nowhere in the cable is this current carrying wire touching ground. Now I'm halfway done. The next thing I do is I go from black, which you may not be able to see very well because it's behind the clamp. We'll try to do it that way for you. And we will then press and hold down the test button again. This is 500 volts. Once again, this is very dangerous amount of current flowing through this wire. Do not put your fingers on the wires when you're doing this. And I'm getting infinity again, which tells me I have no continuity between the black conductor and ground all the way through the mat or the cable.
Now, the thing is, keep in mind with that mega ohm meter is after you test the wires, they can hold the charge for a little while, like a battery pack. So this is a test where I've tried everything. My own readings are good. They're good from core to core. They're good from core to ground, but I keep getting nuisance tripping. And what we would do next is we keep getting nuisance tripping on a system. We eliminate the heating mat or the heating cables by mega ohm metering them. If we shoot 500 volts down this wire and it doesn't trip, it tells you that that wire is good. Nuisance tripping is being caused by something else, like a shared neutral on your power supply. It could be a wiring issue where you're taking a tap off of an individual box somewhere else and sharing it into another box. There's a lot of things that we've seen, especially in bathrooms. If they have an exhaust fan, you turn the exhaust fan on and all of a sudden the floor GFIs. That tells you it's not the floor. It tells you that the power getting to the floor, there's something going on with it. So the first, if you don't get a result from the digital ohm meter first, and it says it's okay, then do the mega ohm meter. A lot of electricians have these. If not, you can have them grab one for you. We also rent these to people. But if you eliminate that floor by doing the mega ohm meter test at 500 volts, it tells you the problem is not in that floor. So if we find out that there is a problem in the floor, notice how wow, it's like we actually planned this segue here. If there is a problem on the floor, how can you fix it? And are these tools available everywhere? How expensive are they? Why doesn't every electrician have all these tools? And I'm going to leave that multi-pronged question up to you, Anatoly.
Thank you, Scott. Yeah, I mean, hopefully I remember all three of them. But first of all, electrician may have, or one in 10 or 1 in 100 electrician may have a variac transformer. It's a relatively maybe lower cost equipment, but yeah, there are a number of things here that are extremely expensive, like a high pot tester. That's why I can probably bet not every every 10th electrician will have this. The good thing, you can rent these directly from us. It's a very simple process. It's the set of tools that virtually will help you to locate 99% of the cases of problems here. To give you a very kind of quick intro here, high-pot tester, which is also called a dielectric strength tester on the upper left, that gray box, typically would be used for locating the breaks. If there is a short present, or maybe that initial break, you zapped it with a high-pot tester and it transformed into a short, the variable red transformer or variac will be then used to look for locating the shorts. Of course, there's also a cable fault finder or short stop. That's the tool that actually measures the distance from the break, from the kind of point you're measuring or start of the wire to your break or short to pretty much to the point of fault. That you can use that if you have a perfectly followed plan, or you can use that just to get an idea where kind of your fault might be. Is it at the very start of the mat, or is it somewhere in the middle or the end of it? And then, of course, we would always provide a repair kits. That's what you will use, of course, in the very end to get that all fixed up. And the thermal camera. I feel like thermal camera are going to win the award today. We use it like almost in every slide. I mean, it's a helpful.
We make heated floors, right? So you're making a heated floor. The camera is definitely going to come in pretty handy.
Yeah. You can first of all use it for just checking for those heat inconsistencies. Like if you remember that slide with the areas that simply didn't have a heating element, that's a very quick and simple troubleshooting to identify and confirm that that spot is cold because there's no heat there. But also it is used in conjunction with those tools up at the top to actually see where your short is or see where your hot spot is by looking through a camera, because of course it's going to show you that visible red glowing spot on the cold floor.
Yeah, we rent these tools to electricians. The high pot tester should never be used by a civilian. It's thousands of volts of power that should be used by an electrician. And the other thing about this digital multimeter, if you notice this thing at the top, that's a clamp. That clamp helps you know what the amp draw is on a specific product. And that's why you need to get a digital multimeter with an amp clamp on it, because we're going to see why that's so important. Now, these tools are thousands and thousands of dollars. That's why a lot of people don't have them, and most electricians don't have them. But the thing is, we rent them, and we can rent them to you. And that way, if you send them back to us undamaged, you'll get most of your money back. We do have a rental fee that we use to maintain this and to box them up, because there's multiple boxes. So each time these go out, they're tested and repaired. So it simply costs, we cover the cost of that by our rental fees. We're not making any money. And I can't tell you the number of times that we've rented these to people who are trying to fix competitors' systems, right? So we don't send this out just to our product. We help supply answers to all the industry. So what else is going to be provided, and what will the customer have to provide?
So yeah, you typically would need to provide the heavy-duty extension cord of the length you need to reach that non-GFCI outlet to use with a high pot. That's a very kind of important and critical part. You want to make sure that at a point where you need to use that high pot, it's plugged into a properly grounded non-ground fault or non-GFCI outlet to work properly. So again, if it's just another room, you may need just whatever, a couple of feet. It might be a completely different section of the house, or I'll probably have Scott chime in on his example where he needed to. Go ahead, Scott.
Yeah, I had to actually run an extension cord to another house because the people that wired it had the line and the neutral reversed on the part of the house that I was working on. So it has to be correct. The hot has to be in the right spot. The neutral has to be in the right spot, and it will not work if you don't have an intact ground.
Yep. And in addition to the kit and kind of rental tools that we provide, you're always going to have a short extension cord with actual insulation removed to connect your output from a variable transformer to a short circuit. So you will see the wire strip there. We're going to talk about this in a couple of slides. And of course, also that cold lead wire to maybe bridge the gap or replace the cold lead together with the repair kits we mentioned earlier.
So some general troubleshooting guidelines. So this is where the ohms, this is why we always start with ohms, because it tells us if we have an open circuit, it tells us if we have a short, and all that stuff. So what are some general guidelines that we use here?
Yeah, again, we try to provide extremely easy to follow instruction that actually connects to these guidelines here. So simply, if you did your own test, you have a break in the wire, maybe start with a short stop, get an idea. Is it at the very start? Is it in the middle through the wire? And maybe it's in the very end. There's an easy chart to follow where you can correlate what the length of the wire you have in your system. And if it's a 300-foot wire and your short stop is showing you 299, it's very likely it might be right in the very end. However, if you already know there's a short circuit, you got the ohms, it's a definite short, use a variac. It just supplies low voltage. It heats that short like we've seen on the previous thermal images. That's how you can very quickly and efficiently locate it and get it fixed. Then, of course, number 3, if there is a break and that break needs to be zapped to either create a hotspot or recreate a short, use the HiPod. That's a dielectric strength tester.
Yeah, so the thing is, the easiest troubleshooting is with a short, because then you don't have to use the high voltage stuff. You can start working at lower voltages. So ideally, if you have a short, that's an easier fix. An open or a break in a wire can be because of those pictures that we saw earlier, where someone drilled through the wire, someone put a nail through it. Someone installed a door stop. Someone got the heating cable too close to the transition where it went from tile into carpet. I mean, there's a whole bunch of things, but the thing is you're actually trying to generate a spark to get past the hole you've created. That's what a HiPod does. It uses a bunch of voltage to create a spark to get past what's impeding it. A short is much easier to do. So a short stop, when I first started here, this is about the only tool I had. I had this tool and some paper that you would lay out on the floor that changed colors when you found a hot spot. So you literally had to take a piece of paper and move it around the floor in the entire room to find it before thermal cameras were affordable. So the time has kind of passed for this short stop, but the short stop will tell you if it's at the beginning, the middle, or the end of the product. Let's take a quick look at the short stop video.
Hello, today we're going to talk about using a short stop device on your WarmlyYours Temp Zone Twin product. When you get the short stop, it will come with the instructions. On the instructions, there are a few simple things to do to get your system working and the test done correctly. The first thing you need to do is you need to find what roll you have in your floor. You'll need to refer to your original order or your installation plan for that. You'll also need to set the velocity of propagation on this unit, which is the VOP.
Sorry, I'm trying to get that shadow.
And then you'll need to find the distance from the beginning of the cable all the way down into the mat or the roll or the cable itself. So the first thing you have to do is you have to find out what roll you have. Well, this wire here is black and red with a ground. That tells you it's 240. If this were 120, it would be yellow, black, and ground. So table 1 is a 120 volt table, so we get rid of that. We don't need it. So all of our information is going to be here on the 240 table. On this table, you need to find out what size roll you have. You also need to find out what the VOP is for the particular roll, and then it will tell you how many feet are in that roll, including the cold lead. So let's pretend that we have a very long roll, and that is a 76-foot roll. So we need to look over here and find the VOP. That is 62. So we need to set the VOP on this unit to 62. To do that, you need to press and hold one of the small buttons down while you press the large button and hold it down. When you do that, you will see a number flash up on the screen and you'll see 65. We need to use the down button to set that to 62. Once we get it to 62, we turn it off. At that point, our VOP is set. We know what size roll we have, and we know what the VOP is. So at this point, we take the red and the black, or if this were 120, the yellow and black wire, we twist them together, and we put the red connector on the alligator clip on the twisted pair, and then we take the black wire, alligator clip, and attach it to the ground. At that point, you then hit the large red button, or the large button in the center, and you get 177. That 177 is the number of feet down the cable that you have the issue. Well, what you do then is you take 177, put it in here, and then you subtract the amount of cold lead that you cut off when you installed it. The cold lead comes from the factory with 15 feet of cold lead attached to the mat or the roll or the cable. What you do is if you've taken 10 feet of that off, you need to take 10 foot off of this number, and once you do that, you will come up with the final number. That will tell you how many feet down the problem is in.
So that tells you how far down the problem is in your heating product. So the short stop device is kind of an older school type thing. All I use this when I do a repair is to find out, is it at 20 feet, which would mean it's at the beginning, or is it 180 feet at the end? This particular cable is 90 feet long. So if this tells me the problem is 45 feet, that's halfway down. If it tells me it's 90 feet, it tells me it's at the end. So the thermostat is shown here, and we have the start point shown here. So if it's 10 feet, I literally know that each one of these runs is 4 feet 6 inches. So there is 9 feet. And you can just start doing your calculations as to how many feet down the cable is by seeing how far it goes in this spot. So that's how the short stop device is used. So let's start talking about the variac process and how we do that.
Yeah, of course. Couple of simple and easy steps to follow here. Of course, number one, you want to make sure that test is also done by a licensed electrician. You're still dealing with a high voltage, exposed wires, things like that. But again, you have a short, you did the ohm test to confirm that. Maybe you did your short stop to pinpoint that, like, hey, yeah, it's somewhere in the middle, just like Scott said, maybe about 45 feet down the line. It at least gives you an island to look at, right? The goal here is we want to connect that exposed end of the extension cord that supplies the power from the variac to your short circuit. So you have two wires coming out of that of that variac, you know, your white and a black. You want to connect that to the short. So if you have a short between a yellow conductor and a ground, you want to connect it there. A very kind of common mistakes is where electrician just simply trying to connect the power from the variac directly to a normal connection on a heating mat. That's not what we're trying to do here. We only trying to supply that power to the short because we want to heat the short. After that's connected, you will place your clamp amp meter, just like shown on the image here, to monitor the amperage. And that's where I think we're going to dive into the next slide with the further steps.
So this is where you have to do a little math. And the more that we know about your system, the better. Because if we know what size product you have installed, we know what the ohms values are supposed to be. So we try to keep this very, very simple in this example because we're not here to do math particularly. But if the ohms of your cable or your mat are 100 ohms and you are getting a short that is at 50 ohms, that means the short is halfway down the mat. Your mat, if it's a 120 volt mat, is designed to be supplied 120 volts. If you supply 120 volts to half the mat, you're going to blow apart the connection you made or the short. So that's why you only are not going to be just taking this knob and turning up to 120. You need to find out if it's a 120 volt system. The maximum I'm going to use is 60 volts because 50% of my mat has a short in it. If this were a 240 volt system, the maximum I would use is 120 volts, but that's not where I'm starting. I'm starting at a different value than that. And the value is going to be achieved sometimes at a much, much lower voltage than that. So let's talk about how we get started.
Yeah, you always want to, before you even plug it in or turn on anything, make sure you start at 0 volts. What we mean by that, first of all, make sure that voltage selector that's shown on the very top of the unit is completely turned to 0. Make sure it's not mistakenly turned the completely opposite direction and it's on the maximum setting. Make sure it's at 0. Plug it in, turn the equipment on. Make sure you are gradually increasing that voltage to whatever level you calculated in the previous calculations. You don't want to just dial it down there. Start increasing that. Keep an eye on your clamp amp meter. It will show you some amperage. And eventually, when you get to your threshold, ensure that amperage is still there. Make sure it's steady and holding. That tells you that something is heating up. And in our case, that's a short. We know there is a short that will slowly heat up.
So keep in mind, inside your system, there are 2 heating wires and there's a ground. So there's like 3 things running inside there. If you're heating from your ground to one of your wires, keep in mind that that area probably won't get as hot as it normally would because you're only heating one of the wires in the twin assembly. So that's what you're going to be looking for. And this extension cord we're showing here, this is the one that we supply with the ends cut out. So you can hook it up directly to the mat and then you can put the clamp amp meter around it. That's why you're getting, people go, why did I get this extension cord with the end cut off and it's all frayed? Well, it's frayed and it's cut off for a reason. So that's why. So at this point, let's say that, Anatoly, let's go back to that previous one and say, you turn the dial, you're getting 1.5 to 2 amps, and then all of a sudden the amp draw goes to 0. What happened?
Yeah, I mean, if your amps drop down, that means, first of all, there's no power being drawn. And the reason there's no power being drawn is very likely there's no short anymore. Again, maybe it was too much voltage. Maybe that short was so fragile that it just disconnected. That's where you will need to dive into a slightly different process with a high pot that we'll cover in a moment. But let's just say your amp's holding steady. Number one, first of all, don't try to increase that voltage from whatever you calculated. That's not going to help you to speed up the process. That's probably going to drop you back down to that open circuit. Give it time. That amperage is going to start heating the short. You're going to start to see something very similar to what we shown here on that thermal image. You will start to see a section of the wire that heats up, and that heat stops at a certain point. That's the point where the actual short is. That's where those 2 conductors, actually the ground and the heating conductor meets together. And that's why there's no voltage going further that point. That's pretty much your short. That's I know Scott said it before. That's how simple. That's your best, easiest approach to the troubleshooting.
So let's talk about identifying a break using the high pot process. And once again, this is high voltage. This should be done by an electrician. And what we're doing here is we're sending a bunch of voltage down these wires to try to get it to jump through the insulation or jump from 2 wires that have been severed. So that's what we're trying to do. So go ahead and talk to us about identifying a break using this high pot.
Yeah, again, that's going to be the process we will be using if there's no short, there's no resistance. Pretty much there's no resistance on all 3 combinations. You will attach the black clamp to the ground and red probe to either black or red and yellow, and you will pretty much start sending these quick 2 seconds burst of electricity to create an arc. What happens, the part that we don't see, we actually will see it slightly in the video, but if it's all covered with tiles, you may not even see that. Your arcing actually happens under the tile. And what's happening, arcing is causing the heat to spike up, and you see that on the thermal camera. Let's take a look on that video.
Okay, now I have got a high voltage tester, which is a high pot. This unit is designed to test the insulation. So if you send voltage down the black wire and you put a ground on the ground, you want to make sure that the insulation is isolating the black wire from the ground inside the cable. Same thing with the red to ground. You want to make sure that the insulation is good all the way through the entire mat. So what I'm going to do is I'm going to take the black clamp, I'm going to put it on the black wire.
Be very careful doing this.
So what I do is I set it up like this, and then I see if I can get it to make a spark. And I do, it resets. So once I'm aware of what that is, I press the reset button and I drop the voltage, and I keep dropping the voltage until I can get it to reset at the lowest voltage possible. This makes sure that it doesn't damage the wire anywhere else. Okay, so I'm getting a reset at about 600 volts. Okay, homeowners should not do this. You should be a licensed electrician and insured before this is, because before you use this, because as I said, you can go from anywhere from 100 to 2,500 volts. So you don't want to be doing this unless you're trained in electricity. So what I'm going to do now is I'm going to push the reset button and hold it down, and I'm going to hit this with short bursts of only 1 or 2 seconds, maybe 3 at the most, and that's going to show a hot spot in the floor. Okay, now that we found the spot, I've marked it with a black magic marker, and what I'm going to do now is I'm going to break up the thin set around it so I can pull the cable up to make the repair. I always hit, you can see the cable runs here and here and here. I'm going to run break it up in between the wires, so that way I'm never ever going to hit the wire with any of these tools. See, not only do we worry about right where the spot is, but we've got to be able to lift the cable up to make the repair. Right now we're pretty lucky because we had the bad spot. We found it before the tile went down. But you can still do this repair even if there's tile on top. That's what's so great about this, because you can use a thermal camera to find that hot spot. Now if you can see, I've gone right after where the bad spot is. We're going to have to cut through there anyway. So I need to be able to get this cable up. So I'm going to go right at the bad spot.
And you can see that cable's been physically smashed. And what happens there, people using ladders, that sort of thing, and that can cause those kind of problems. Once again, we talked about setting down or dropping a big pail full of thin set. That can cause that too. So once we found the spot and we do that, what's the next step?
So yeah, next step, we need to remove whatever's on top of it. The goal is, of course, get to the actual level where the wire is, expose the wire, or simply expose at least a couple of inches of wire on each side of the damage to either create a shorter loop like we are showing here, and kind of similar was on the video, and create your repair, connect these wires back together.
Yeah, you take a look at this picture and you can see where it's been skinned, where physically, I think someone took a trowel across this, and not only did they skin the insulation off, but then they got down and damaged the wire inside of there too. So the one thing that's great about this picture is probably one of the biggest bit of misinformation out there supplied by electricians troubleshooting these situations is that, oh, there's a problem in the floor, you're going to have to replace the entire floor. You don't have to replace the entire floor. You can see you'd find the spot where it is. You take up that tile. When you do the tile, do the repair, don't try to lever it up off of another tile. Just take the tile and smash it, and then start picking the pieces up and keep smashing it until you're able to lift it up. So once the issue has been identified, only a small section of the flooring is actually going to need to be repaired. And here you can see, I can tell you what happened at this house. The installer did not tell us that they had an air vent here. This is why it's so important to tell us, because what they did is you can't heat over an air vent. So they just put the wire too close to the air vent. And when they put the metal air vent in, it got smashed. And we had to replace that section there because the wire was damaged, because the plan they gave us didn't indicate where that was, and they were stuck. They didn't, because what happens when you take these areas and you put air vents or tubs or stuff like that, you're actually removing the heatable area of the floor. You're reducing the square footage that's available for the heat. Well, you start doing that, you're going to start running out of space. And that's what they did here. So perfect example of what goes on there. So let's take a look at putting these repairs, doing them and getting them put back together. So grab some popcorn. This is riveting.
Okay, what we're going to do today is we're going to do a twin conductor temp zone repair using these parts that come in the repair kit. We have a 6-inch piece of 3/8 inch adhesive lined heat shrink tube, which can be located or purchased anywhere. What you want to do is make sure that you get adhesive lined or dual wall, whatever they want to call it in that particular case. You can get these at Fastenal, and the Fastenal part number is on our instruction sheet that will come with the kit. Also, with the kit, you'll get 2 insulated butt connectors that are also heat shrink, that also have solder in the middle that we're going to melt using a heat gun. And we have an uninsulated butt connector. It's to connect the grounds together once we get our repair done. So the first thing we're going to do is we're going to take a look at these wires, and you can see on the instruction sheet when you get it that the wires have been cut about 1 inch back from where the bad spot is. You go about 1 inch back, and then you cut one connector, one wire shorter than the other. That helps offset these two when they're right next to each other. These will shrink up, so they will become smaller. So you kind of want them offset. You don't want the thickest parts to rest against each other. You kind of want them to rest like that, so they fit in a little bit better. And that's why they're cut as so. And you can see this on the instructions. So once we get 1 inch back, we get our grounds tied together, and then we make offsetting cuts, we can go ahead and start doing the repair. The thing is, when you're cutting these offsets, you want to make sure that you do the exact same so they match up perfectly. So use some sort of gauge that you can go 1/4 inch or whatever you decide to do. I use a cutter so I can make the same distance cut on each one. So before we start to put these on and these on, we need to get the adhesive lined heat shrink tube on the wire in advance, because you can't put it on afterwards. So we're going to take that and put it over our spot here, and then we're going to get our wires lined up. We're going to take this and get it out of the way. The uninsulated bud connector is going to be done last. So what I'm going to do is I'm going to take this and I am going to put that on there. You can feel it mechanically stop. It'll only go so far. And once you do that, you then make your connection and crimp it down, and that will hold it in place. It's very important when you use these wire strippers, they come with a connector crimp at the end, and you will see that the red matches the pink. If this were 16 to 14 gauge, it would be blue, but these connectors are pink. So that tells us we're going to use this outside spot to make our crimp. So what we do is we get our thing on here real well, get it out of the way, making sure that the wire stays in while we crimp it down. We crimp it really, really well, and then once we make our crimp, we pull on it to make sure it's tight, and that one is tight. So the next one we're going to do is we're going to, that was our short side, so now I'm going to put the long one from this one in here. So we take our crimper again, and squeeze very tightly and pull. If you can pull on it and it doesn't go anywhere, that tells you your connection is really good. So what we're going to do in the very near future is we're going to get that sealed up So it was going to give us some room to work on our next connection.
One thing I neglected to tell at the when I did this video years ago is we have the solder in the center here, and you can see that solder bead is in there. What we want to do is we want to seal the ends first, and then that way we can melt the solder and have it not run out. So if you melt the solder first, it's going to run out of the connector and cause a problem with ground fault down here. So seal the ends first, then melt the solder. You can also do this with solder, but you have to be have a good talent with a soldering iron to do that. That's why we're showing this side.
A quick look here, you can see where our solder has melted in the center, and we can see our wire very well through the pink connector. If you can see it really well, that means it's gluing itself onto the wire. So we can get a good idea whether our connection is going to be good. So we have a nice clear wire that we can see. Eventually, as it cools off, it's going to turn opaque. But we can see that the solder has flowed together. So now, not only do we have a mechanical bond between the two wires, we also have a solder heated bond between those wires and the solder. So that connection is not going to come apart. So we're going to let that connection cool off a little bit. And once it cools off, you'll see that it turns opaque. So now it's time to take our second butt connector.
Notice how this wire is not stranded. It's a single run of wire. And if you're tempted to use the old-fashioned red ones, please don't, because they don't have solder in them. And this is what you want to use.
Tool. Once we make our connection, pull on it, make sure it's tight. Then we make our next mechanical connection. Then we pull on that connection, and it's nice and tight. So that tells us our connection here is going to be good. And now we're going to add the heat shrink and melt the solder inside there to make it even better.
Sometimes this heat shrink is called marine grade. If you don't see dual wall, or if you don't see...
It's very important to get around the entire heat shrink, because if you only shoot it from one side, it will not contract all the way around. So we're going to make sure that we do that all the way around.
Then watch for the solder to melt.
Then we're going to, now that we have our seal, we're going to melt the solder.
And there it goes.
And you can see the solder flowing inside. We can go ahead and get our grounds connected, and to do that we use our uninsulated butt connector. So the reason this is so we can use an uninsulated butt connector is because the voltage carrying wires are isolated from the ground now. There's no way they can touch. So we don't have to worry about doing this insulated. You could use a drop of solder to hold this together if you wanted to, or you can just use this butt connector, and that's what we're going to do. So there's our ground connection on this end. Make sure you don't have any stray ground sticking out. ground connection is nice and tight. And now it's time for us to get our final layer of heat shrink tubing onto the wire. Now, if you look here, we can see that we send you 6 inches of this tubing. You're not going to need 6 inches to do this repair. So if you have to trim it down a little bit, you're more than welcome to do that. But you want to just make sure that you get the wire covered. So we know our repair is right here. So we go ahead and see how that looks on the tube. It means we can scoot this over a little bit. That looks about right. Remember to get all the sides, to get it all to shrink uniformly. Now when you do this, it's a good idea to get it really tight all the way from here to here to make sure it's nice and constricted, because there's glue inside this tubing, and the more glue you have adhering to the wire, the more chance it has of being waterproof. So you make your connection here, and then you go ahead and get your waterproof seal done inside here. If you don't get it done exactly right, you can put a little RTV sealant or some liquid tape or something like that to fill the gap if you don't get a nice tight seal there. So there we can see what our repair looks like, and we're all done.
Then once you're done with the repair, then you do an ohms reading. And what I like to also do is when I'm done with the repair, I like to zap it too, just to make sure that it doesn't cause any more problems. So what are the final steps, Anatoly?
Yeah, like I said, do that ohm test. Do that right when you maybe just connected the wires to ensure that all is intact. Do it after you get your crimp solder connectors in. Kind of, you can do that at those intermediate steps just to ensure you are on the right track. And of course, do it at the final, do it after the floor covering is on to ensure everything is successfully finished.
Yep, and if you want to run it, because that way you can check the GFCI, you can let it run for a little while. Never let it run overnight uncovered. You can let it run for 15, 20 minutes uncovered, but that's it. Cover the repair, and then you can run it later, but you're going to need to finish up there. So questions, we got through this. It was if you're thinking, wow, this was long, well, we just wanted to make sure that everybody saw exactly what happens, because we're always dealing with people saying you have to rip up the floor, you have to rip up this, you have to do that, it doesn't work. You don't have to rip up the floor. So very, very important to realize that these situations can be headed off at the pass. You can have a pretty good idea where the problem is and what the problem is before you even break the tile. That's what's so important with the thermal camera and the other troubleshooting, is you get an idea where it is, and then you just break the tile where the problem is. You don't lift up the whole floor. So, Anatoly, do you want to take the first question from Kenneth, and then that'll give some time for some other people to put their questions in?
Yeah, let's see. So what did we speak with Ken? So he mentioned there was not a voltage issue. It's a 120 volt system. Tile installer is attempting to say there is a break. And okay, so we're trying to understand if there is a need for repair or no. So I think it kind of connects to I would say to what Peter was asking earlier. I think number one thing is, yes, do your ohms test, do your mega ohm test if it's needed, because that is what will confirm, is there a break or short, or is that wire is completely normal? There is no fault in there. I think unless we have any additional information, that's going to be the best direction to take here.
Yeah, absolutely. Do ohms. So that's going to be that for Kenneth. So thank you, Kenneth, for that question. And also, we are going to move on to Peter. I think Peter, the question he has was answered by our presentation. He has a couple of floors that are heated, each have a Crestron thermostat, and he's using the integration kit. Each of these kits connected near my breaker panel. One of the floor trips the GFCI breaker every 2 to 3 days. Floor ohms is equal to the label. Okay, that's one reading. I think you've got 2 more to do. So I hear you, the floor is probably good. The way you know the floor is good for sure is to do a mega ohm test on it. If the mega ohm test is good, that would tell you that the problem is in your electrical power. He swapped thermostats and integration kits with no change. Is this a nuisance strip? Yes, it's a nuisance strip, possibly with a breaker, or should I try buying another one? What's the red flag to me here is when we read stuff like this, there's usually a red herring or a red flag that pops up. And the red herring in that statement is that that the kits are connected near my breaker panel. Well, when you're connect near a breaker panel, that usually tells me that there's some wiring that the electrician supplied between the breaker panel area and the floor in that room. I would test the ohms in the junction box in the room first of the mat. And if they're good, and if the mega ohm reading is good in the room, then the problem is either in that extension wire to get from that room over to the breaker panel, or there's something going on with the breaker panel. But is that the same red herring that you would have, Anatoly?
Yeah. I mean, I agree with all that, and I would say if we potentially suspect a breaker and it's relatively simple and quick thing to just replace, after you go through all of these steps that we kind of covered now, yeah, definitely go ahead and try replace a breaker. There might be a 1 in 1,000 defective breaker that maybe went in here and that's what's happening. But also, I kind of have that connection to that nuisance with, like Scott was mentioning earlier. Hey, when actually it trips? I know you mentioned 2 or 3 days, but is it maybe tripping every time that fan kicks on? Maybe is it tripping every time some other combination of equipment, appliances, or fans or lights being turned on in the house? That may give some additional clues.
Yeah, so that's why the mega ohm is so important to get the floor ruled out. Because if you can rule that floor out and that floor is good, it's something about getting the power to it. So hopefully we've given you a couple of good things to look for there, Peter. Thank you for your great questions. We have additional training Tuesday, Wednesdays, and Thursdays at 4 o'clock. The next seminar or webinar is going to be Mastering Electric Snow Melt Systems, Planning, Installation, and Operation. That's going to be the same time here as we are as we are doing today. The April 2025 promotion, save 15% on select temp zone products. You can visit our website to learn all about our ongoing promotions. And we'd like to thank you for joining us today. And Peter, or looks like we have a question from Oscar real quick. Oscar says, how many feet of power cable can I add to the mesh and what type of cable is recommended? The power cable, you shouldn't, any splicing of the power, if you're talking about the non-heating lead, the non-heating lead from the heating product has to be run into a junction box in that room. And then you can add whatever you want to from that junction box, say back to a breaker panel. Always check your local code to see if you need to have a disconnect in the room that the heat is located in. But you never add any wire to our assemblies. You get the assembly installed, so you never ever install extra or take and remove heating wire. And the non-heating leads need to be run to a junction box. And from that junction box, you can add however many feet of cable you need to get it back to the thermostat or to the breaker panel or wherever that is. So that cable that you use is going to be required by your local code authority. So always check with that. So always check with that. And we like to thank you. And Anatoly, thank you for joining us today. We are going to see you next time. Have a great day. Be connected, be warm, and
Be radiant.
have a good one. Take care.
Bye.